Thank you, Madam Chairperson, and good morning to all of you. So I present to you the ecological damage of illegal mining water bodies and forest management in Ghana. Next, please. Okay, so the CSIR in 2016 predicted that by 2030, we are going to have a water crisis in Ghana. In 2016, we noticed what the illegal mining effects are. And so we made a prediction. We are just 5 years to the end of 2030. And if things don't change, I'm afraid this will come into fruition. I pray it doesn't. But we must work towards it. Next, please. So this is going to be my presentation outline. I'll talk about the river systems in Ghana, overview of Galamsey activities, the water quality index, treatment costs, forest reserves, and then the cost estimates. Next, please. So this shows the global water budget. So 97% of the global water we have is seawater. It is only 3% that is available to us as fresh water. And of the 3%, only 13% is accessible because the 87% is locked up in ice caps and then glaciers. So if you compute 13% of the 3% is 0.4% globally. So globally, we have just 0.4% fresh water. So we must take a second look at what we are doing. Next, please. Now, when you come to Ghana, we have classified our rivers into 3 systems. We have the Volta river systems, comprising the black, the white, the red Volta, OT, and the main Volta, making up 70%. Then we have the southwestern rivers, comprising of Tano, Bia, and Cobra, Brim, Ofin, making up 22%. And the least is the coastal rivers. That's Chinakwa, Ayensu, Densu, also making up 8%. So these are the 3 river systems that we have classified in Ghana. Now coming to the Galamsey issues. The country is endowed with mineral resources, and gold accounts for 90% of all the resources. However, illegal mining has devastated the areas, vast areas of the country. And as we speak, 60% of our water bodies have been contaminated. The toxic metals employed include mercury, of course, arsenic is a byproduct, lead, cyanide. And these have rendered many drinking water unsafe. It's also bioaccumulating in fish and entering the human food chain. The use of mercury began about 50 years ago when it became too difficult for the small-scale miners to extract the gold from the rocks. Now, the optimal ratio of mercury to gold is 1:1. But in Ghana, most of the Galamseyers use a lot of the mercury. They do so because they want to ensure that all the available gold is amalgamated or extracted. So they use excessive mercury in the extraction. And that is where the problem sets in. This shows a typical flow chart of the artisanal gold mining. So the ore is crushed, mixed with water, concentrated, amalgamated, and then heated to get the gold. In so doing, they make use of the nearby rivers or water bodies. Now, how does the mercury get into the system? So from the concentrate, it is amalgamated. So the amalgam is a mixture of mercury and gold, 1:1. So when the amalgam is heated, the mercury is released into the rivers, of course the sediment as well, and the fishes. And then through the heating, it escapes into the atmosphere. The workers and passers-by also inhale the mercury. It gets into the soil, and eventually it contaminates our vegetables and other food crops. Next. So these are the problems associated with the illegal mining. There are a lot. I'll just list a few, especially the contamination of food and cash crops, depletion of our forest reserves, and then the degradation of our water bodies. So these were the scenes in 2018 from the Ankobra, Brim, and the Pra rivers, from different sections of the rivers. Next. Then they became worse as the years progressed. So these were the scenes in 2024. Densu at Akwadum, Enum at Konongo, Ankobra Prestia, and the rest. Okay. So the top photo shows the uncovered pits, ducts, by the small-scale miners. So this is from the Ankobra Basin, and that one is from the Pra Basin. So currently, as we speak, next, all the southwestern rivers are heavily polluted, and then they are also laced with high turbidity levels. In the midst of our woes, we also have foreign nationals involved. And whilst we are crying, they are enjoying the chibum. And that's the irony of the situation. Now, this chart shows the turbidity values from 2017 to 2024. Now, as you recall, in 2017, the government placed a ban on illegal mining. So if you see that between 2017 and 2018, there was a drop in almost all the rivers because of the ban that the government placed. Now, after the ban, then the levels began to shoot up again. So this is where the ban was placed between 2017 and 2018. Next. Now, these are the current values that we are getting from the headworks. So this is the Pra River. Now, the blue line denotes the capacity of the plant. So for the Dabuasi, the capacity is around 200 for turbidity. The plant is designed to contain this capacity. Now we are getting 10,000 plus. In the same vein, if you come to Section Himan, that's the blue line is the capacity for turbidity. And we are getting 8,000 thereabout. Currently, it's around 8,000. So the same goes for the Brim River at Osino. The capacity is around 50, and we are getting also around 10,000 or thereabout. So it goes on and on and on. So all the plants are exceeding their capacity in terms of the turbidity. So this is the current values I obtained between January and April. So these are the average values. So as I said, the Section Himan is around 8,000 as we speak. Then we have the Dabuasi. So if you have between 0 and 150, then we'll say we have a low turbidity. And then more than 500, we are saying the water is polluted. So except the Koforidua headworks, which takes its source from the water lake, all the rest are heavily polluted as we speak. Next. So we all heard of the Konyakun shutdown, and that is the treatment plant at Konyakun. Please, okay. So that is what goes on at Konyakun. That's the color of the water that they treat. No wonder it was shut down. We have others which have been shut down. I will show in the next slide. But this is from the Konyakun treatment plant, which was shut down recently. The next. Good. So these are official values obtained from Ghana Water Limited. So they are not just conjectures. So all these have been shut down. As we speak, it's only Bonsa and Konyakun that have started operation, but they are not yet to their full capacity. These three, just this morning I confirmed, because 2024, I was surprised. I confirmed this morning, all the three are still down. They are not in operation. So I asked my colleague that, where is the source of water? And he said the other source, it could be the tanker water or probably from borehole. So these three have been shut down as we speak. Next. Now we have two ways of assessing water quality. Either we use the WHO guidelines or the Ghana Standards Authority standards. We could also use the water quality index. to assess or classify a water body. So for the water quality index, we measure these parameters and then use the Solway water quality index to classify. After measuring them, you integrate them and into a single number to 0. Now, when you are done, you have to go through a process. We classify them into good water, fairly good water, poor water, and then grossly polluted water based on the percentages. Okay. So after you have computed, for more than 80, we say the water is good or unpolluted. Between 50 and 80, we say it's fairly good. Between 25 and 50% is poor quality, and then less than 25% is grossly polluted. So this is a Solway classification of water bodies. Now this was earlier, between 2005 and 2008. And after computing, we noticed that most of the rivers were in the class 2. That's a fairly good. That was the earlier stage. Currently, as we speak, they are in the class 3, moving slowly towards class 4 if nothing is done. So this is between 2005 and 2021. So they are mostly in the class 3 stage. The class 3 is of poor quality. If nothing is done, then to move into the 4th stage, that is poor or grossly polluted water. Now let's look at Ghana's water scarcity. Okay, so these were computed without environmental stresses. So if you take an individual like you or I, the water that you have is 1,568 meter cube per person per year. So per year, this is the water that individual will have for cooking, for drinking, for bathing, blah, 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 blah. As the years go by, you see that it's decreasing because of population size. Once again, these are without environmental stresses. So when the environmental stresses come in, then the situation will be very serious. If you take the water basin, so this is the amount of water per person for those who rely on the water basin alone. So once again, the values are decreasing because of the years, 2030, 2040, and the like. So this is the outlook of Ghana's water scarcity without environmental stresses. And as I said, if you bring in the Galamsey and other issues, the values will be very, very, very low. So currently, if you take the Densu, it's under water scarcity. If you take the green one, PRA, also, this is absolute water scarcity, and this water scarcity. The blue one is the water basin, and this is under no stress. Of course, these are also under no stress because of without the stresses. But if you bring the stresses, they'll move to the water scarcity area. The next. Please move on. So the current situation has resulted in water scarcity in some areas. As we notice, some treatment plants have been shut down. So as a result, there's a need to reflect on what is going on in terms of the costs involved. Next. Now, this is a scenario I want to project. So, from a treatment plant, let's say we have a raw water volume of 111,000 meter cube of water. For drinking water, the turbidity must come to 5 NTU. Now, this is the turbidity of the water we are talking about. The color should be between, 15 is for WHO, and then the Ghana standard is 5. And this is the color of the water. So in treating this, to get these turbidity or color values, we will need about 110,000 cedis of chemical. Electricity will cost about 77,000. So if you put the two together, if you have to treat this to meet the guidelines, then we are spending about 200,000 Ghana cedis. This is without other costs. I'm only focusing on the chemical and electricity costs. Oh, please. Now, conventionally, for water treatment, the allowable loss is 10%, maximum 10%. But because of the Galamsey issue, this amount of water goes into waste. So instead of a loss of 10%, we are losing about 22% of the water because of the polluted state of the water. Next, okay. So, these are the monies or the cost spent by Ghana Water. These are official figures. So in 2022, they spent 96 million cedis just on chemicals for the entire country. Just on chemicals. In 2023, they spent 222 million cedis. 2024, they spent 282 million cedis just on chemical costs. And these are official figures obtained from Ghana Water Limited. So they are not just conjectures. Well, this year has not ended. But looking at the trend, it could go high. Now let's look at this scenario. I've selected some river basins. These are the drainage areas, the lengths, the weight, and the discharge. So when we take the Pra River, the amount of water in the Pra River is 4.83 billion cubic meter. Can you treat this? If you take Ankobra, the amount of water in the Ankobra basin is 1.20 billion cubic meters. Now currently, Ghana Water Limited spends between 10 and 15 cedis per meter cube of water. For each meter cube, they spend between 10 and 15 cedis because of the Galamsey issues. Otherwise, it will be around 5 or less. Okay, let's take the lowest amount, 10 cedis. So, if you are going to treat the Pra, this is the volume of water we have. So multiply this by 10. So we need 48.3 million cedis to treat just the Pra alone. Do we have that money? If you take Ankobra alone, you need 12 billion cedis because each meter cube is 10 cedis. So it's that simple mathematics, multiply by 10. So we need 12 billion cedis to treat the Ankobra, and it goes on and on. So the situation is very critical. Now I want to move on to the forest reserves. We have 288 forest reserves in the country, and that covers nearly 2.6 million hectares. And as we speak, 44 of the forest reserves have been affected. And these are the breakdowns. In fact, I have 5,200, but I think this morning Mr. Kotoko said it's around 10,000 or so, if I'm right. Okay, so I need to revise this. But this is what I had before coming. So these are the forest reserves which have been affected. So Ashanti region tops with 14, Western region 12, Western North is 12, Western region is 11, and the least is Savannah, which is 1. So these have been affected. In fact, Erastus Asaredonko also confirmed this in June when we met at the Ghana Academy of Arts and Sciences. And then there was a remote sensing studies done between 2018 and 2023. And that shows that around 5% of the forest cover will be affected, annually. Okay, so what are the causes of the infiltration? So I have classified them into 3. We have the institutional issues, logistical issues, and then political. So the institutional issues involve the weak enforcement, overlapping of the mandates, the Forestry Commission, Environmental Protection Authority, Mineral Commission. And we think sometimes there are overlaps in the mandates. And as a result, this impedes the effective monitoring and prosecution of the offenders. If you look at the logistical issues, we have the inadequate patrols, lack of surveillance equipment, inadequate legal deterrence, and these have allowed the miners to operate within the reserves. The political issues comprise of the political interference, complicity by the local authorities, and these have also undermined the national anti-Galamsey campaigns. Next, please. So talking of the impacts on the forest, it affects the forest resources, including the reserves, and this will also eventually have a toll on the biodiversity as well as watershed protection. It also impacts on the deforestation, and then it also alters the hydrological system. Then you have the ecological consequences that go beyond just the removal of the vegetation to the disruption of the natural structure. Next. So it continues. The ecosystem services are also affected, talking of the carbon sequestration, the soil stabilization, and then also the water regulations. These are all undermined and threatens the environmental sustainability goals. So what can be done? If you ask me, the first thing is to stop Galamsey. And let me state here that no matter the intervention that we put in place, if the Galamsey is not stopped, I can assure you it will yield nothing. It's like going to fetch water in a basket. You fetch the water, everything is poured out. So we must target stopping the Galamsey. I showed the Pra River, about 4.83 billion cubic meters. Are you going to treat all this water? Even granted that we treat all the 4.83 and the Galamsey is not stopped, what have we achieved? Even granted that we have treated all and the Galamsey is ongoing, what have we achieved? So the first step is to make sure that we have stopped the Galamsey. I mean, we must find alternatives. We can discuss that during the second session. My sister institute, the Forestry Research Institute of Ghana, is also doing some trials with some species to plant on the degraded land. So once the Galamsey is stopped, I think we can also start implementing some of these things to restore our degraded land. They are doing some trials at Kumasi. So these are some cost estimates and interventions. For instance, if you want to tackle enforcement using drones and patrols, the Ministry of Lands and Forestry, Natural Resources, in 2021 estimated 40 million cedis over a 5-year period. These are all the resources. Dollars, $40 million for the 5 years. And in talk of plant enrichment, we will spend around 50 million cedis for 5,000 hectares of land based on Forestry Commission 2020. Photo remediation, about 3 million cedis for 20 sites. And if you want to stabilize the river banks, we will need about 5 million for 100 kilometers of land. And these are the references. Education and then sediment dredging. We also need about 10 million cedis just for 10 rivers. And these are from the EPA and the Ghana Water Limited in 2021. So these are mainly from 2021 and 2020. So definitely now the figures or the amounts will go higher. Okay, so some challenges and proposed solutions. So the challenges are the high cost of the remediation technologies, weak enforcement of mining regulations, resistance from communities who depend on the Galamsey incomes, and a limited technical expertise. So the proposed solutions, there must be political will to enforce the regulations. There must be temporary mining moratorium. If you stop the Galamsey, we have something we call self-cleansing or self-purification. The water can restore by itself. That is when you stop the water. Because every river has its source, and the source is usually not polluted. So assuming everything is washed into the sea, then the source will replenish the river. So if you leave for about 3 to 5 years, I'm very certain that the rivers will be restored. You also have the community participation and a multi-stakeholder collaboration or engagement like we are doing now. So I've been signaled by my chairperson. So I want to draw some few conclusions that the quality of water is declining and future water scarcity in Ghana will grow, driven by the population as well as the climate change. The Ghana Water Limited is facing severe challenges as a result of the heavily polluted water coming to the treatment plants and associated cost of treatment. The Galamsey menace is an existential threat to food safety and public health, national security, as well as Ghana's ability to achieve the SDG goals, particularly Goal 6. Therefore, it should be tackled with all the seriousness that it deserves. Now, the entry, I don't know if it has been passed. Maybe my MPs will educate me. But I think around October 14th, the Attorney General Minister said he will lay the LI 250 in Parliament. I don't know if it has been laid. Not yet. Oh, okay. So if you do that to replace the LI 2462, then this will prevent the mining in forest areas, and then it will halt the biodiversity loss as well as soil degradation, among others. On that note, I want to say thank you very much.